Hello everybody, this is Mr. Munson. We're at Unit 3, Parallel Lines and Transversals. Um, it's Concept 2, so we're calling it 3.2 of course. Parallel lines in the coordinate plane. So we're going to be writing equations and things like that with for lines, linear equations. These are things that you've done before in the past in Algebra 1, and so I'm not going to go into absolute super detail. So these are some of the things that you should already kind of know, and so this is kind of a refresher. If you're struggling with this concept, especially if you struggled in Algebra 1, you need to come and see me, and we can do some stuff after school, and then or just go on Google and you can look up some of the questions that you might have. Let's get started. So in the last video, we had a vocabulary list that was quite extensive that we filled out. We almost finished it. We were down at the bottom where it starts off with slope. That's where we're going today. Okay, slope of a line. Slope is a ratio, if you will, a fraction. A ratio is a fraction, a number over a number, of vertical change, y2 minus y1, and horizontal change, x2 minus x1. And so if you take a look at the third column over, I have the x and y axis drawn in black. I have a blue line and a red line. And so these lines have slope. It's a ratio. We'll talk about it a little bit more in the video in just a moment. But the red line has a negative slope, and the positive line blue line has a positive slope. All right, so an example in the last, I might say m equals 5 halves. What that means is the slope of some line is 5 halves. I calculate that by taking the 2 points, if I have 2 points on the line, and I subtract the y's and I subtract the x's, and I end up with this 5 over 2. And basically it means a relationship, a ratio between the up and down movement of the line and the left and right movement. And you probably remember your teacher last year referring to it as rise over run. So when we take a look at the next line, we have a slope form of a linear equation, also known as slope-intercept form. And so this is like the standard equation. If you remember, we had standard equations for a circle. That was x minus h squared plus y minus k squared equals r squared. Well, for straight lines, we have a standard equation as well, and it's y equals mx plus b, where the m in the equation, the number that's in front of the x, is the slope, and the b, which is the number that will come at the end there, is the y-intercept. Okay, so take a look over a little bit further to the right there. You'll see an equation I wrote in red, y equals 3 halves x minus 1. And so what ends up happening is that minus 1 tells me where the equation or where the line crosses the y-axis. That's the b y-intercept. It intercepts the y-axis, that's the vertical axis, at -1. So I can put a point at -1. There's one there drawn already, of course. So then the number in front of the x is a slope. So if you take a look at that, it's 3 over 2. And 3 is a positive number, so that represents a number going up in a positive direction, okay? So if I walk from the point at -1, if I walk up 3 and then over 2, I end up on my line. And then I could just simply draw. Once I have those 2 points, I could draw the line. Now that was already pre-drawn, and so go ahead and feel free to copy that in. Let's move on next. Okay, next up is coplanar lines. Parallel lines. Parallel lines are coplanar lines that never intersect each other. They have the same slope. Okay, so if you look over in the far, if I had the m equals a over b, so m representing the slope of some line, if that was some number, let's say it was 3/4, in this case I wrote down a over b, then the line that's parallel to it has exactly the same slope, the same ratio, a over b. So take a look at the graph there. I have my x and y axis drawn, and the blue line and the red line have the same slope. It's up a over b on both the lines, and I end up back on the line. Let's move. Perpendicular lines. Two lines that form a right angle. Okay, so if you look at my x and y axis there, I have a red line and a blue line, and they meet at a right angle. That means that those two lines are perpendicular. Both lines have a slope. What we find is the slope is not what we say opposite reciprocal to each other. Opposite means one's positive, that would be the red one, and one's negative, that's the blue one. And the reason it's positive and negative is you need to go back up to the line that says slope of line, and you can see where I designated how lines are positive and negative in slope. Okay, so the slopes are opposite. Reciprocal means that if, let's say, one of them is 3/4, the other one is 4/3. Now, we didn't take the opposite there, but reciprocal means take the number and flip it. So if you look over the far column, it says if m is equal to a over b, so if the slope of some line is equal to a over b's, two numbers, then the perpendicular slope is equal to opposite of b over a. So if one's negative, the other one's positive, and then you just take the numbers and you flip it, put one on top of the other. For example, suppose I had the slope of some line called 1, and I called it m1. That's the slope of line 1. And so that is equal to 3/5. The perpendicular slope to that would be -5/3. So now what I'm going to do is I'm going to give you an example. I'm going to chance to do your own. So if you take a look, I just exposed the slope of some line 2. The slope of that line is -4/7. So put me on pause, or just pause me, or just write down very quickly what you think the perpendicular slope would be. I'm hoping that you wrote the perpendicular slope was 7/4. So one's positive, one's negative, and then you just flipped it. The 4 became a bottom number and the 7 became a top number. Let's move on. So given lines in the coordinate plane like this, we can find their slope by plotting some points and just basically drawing some lines and finding out what the slope is. So we're going to do that. We're going to test our ability to do that here. I want you to follow along. Certainly draw these equations on a piece of paper, a graph paper, whatever you need to do. So the way you do this is you're going to find points on them on the line. So look at the blue line. So find some points. So basically what I do is I go find where the line crosses one of the corners of the boxes. Okay? And then I find another one. And now I have 2 points. And what I do is I find out what the slope is by going up and then over, rise over run. So since I went up, that's a +1. Since I went to the right, that's a +3. So the slope of the blue line is 1/3. Now take a look at the red line. So again, we'll go and find a place where the red line crosses at the corners. There's a point there. There's one way up here. So let's find the slope of that line. So again, what you would do is you would simply go up, in this case 2, and then run over to the point. So I went up +2 because it's up, and then I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. So that slope, let me turn that into a red. That slope is equal to 2/10, which is equal to 1/5. We always reduce our slopes. Now looking at the green line, again, find 2 points. There's a point right there, and there's another point right there. So let's find the slope of that one. So I'll go up 1/3. I went up 1/3. So the slope of that one is, again, 1/3. Okay, so this is what just happened. I noticed that this slope right here and this slope right here are the same. Those 2 points are the same. Now I'm going to change that one to green so it's a little bit easier for us to see. All right, so those two, the blue line and the green line, have the same slopes. What I now know is these two are parallel. Okay? Whenever 2 lines have the same slope, they're parallel. Well, let's take a look at these. Obviously, the blue line and the red line are not parallel to the green line. They intersect with it. Now, I'm not too worried about if the blue line and the red line are parallel. I'm more interested in seeing if the blue line and the red line are perpendicular to the green line. So let's get their slopes, and what we find out from the reading above is that perpendicular lines have opposite reciprocal slopes. Now, we already talked about that. Now, interesting thing is once we have the slopes, if we're not sure if they're opposite reciprocals, we can multiply them. That's what product means. And they'll equal, once we multiply, to -1. This is how we would write 2 lines are perpendicular. So I'm going to plot some points and I'll read them to you, and then I want you to go find the slope, okay? So on the blue line, I have the point -4, 1. Okay? And then the other point I wanted to look at, let's just find another one, is right here. And that one is -5, 3. Okay? Now we certainly could use the slope formula, but what I'd like you to do is just simply draw in what you think the slope would be. So I got the slope of that line to be up to -1. It's negative because we went to the left. Going to the right is a positive number. Let's do the red. Okay, so the red line I got to be 3, -2. All right, let's find the slope of the green one. So for the green one, I found this point here and this point here to be a place where it crosses the corners of the box. So this is 2, 4, both of them positive. All right, so if you take a look at the first one, the blue one, I can rewrite that as -2/1 or -2, it doesn't matter. And the red one, I can rewrite just to kind of clean it up. We don't usually put a minus sign in the bottom, so we can call that 3, -3/2. So if you take a look at the blue line and the green line, you see that their slopes are opposite. One's positive, one's negative, and reciprocal. They're flipped. Now we could take the product and multiply them to just double check. And sure enough, those two slopes, when multiplied, equal -1. That means that the blue line and the green line are perpendicular. Okay, in this problem, they ask you to determine if the lines are parallel, perpendicular, or neither. So it's just going to be a matter of us doing the slope formula. So what we're going to do is we're going to take the points for A, B, and we're going to plug them into the slope formula. Whenever that's a subtraction of a negative number, I always circle it and put a plus above it to help me realize I just add those two numbers. Okay, and there's the slope of that one. Go ahead and put me on pause, and I now want you to find the slope of CD. All right, so what we find is the slope of AB is -7/5, and the slope of the CD is -3. Now I just realized I made a mistake over here on this part right here, so let me just do some alteration to fix the math there. Okay, so back to the corrected math, that's been updated there. So what we look at is these two slopes, one for one line, one for the other, and since they are different, that tells us that the lines are not parallel. Since they're not opposite reciprocal, they're not perpendicular, so they're neither. So now here's your chance to check to see you understood the math before and that you can do these kinds of problems. Let's go ahead and answer the same problem, type of problem using the math that we did before. Practice it up, find the slopes, determine if they're parallel or perpendicular. Put me on pause, and when you get back to me, we'll look at the work. Okay, there we have it. The slope of AB is 2/3 or 3/2, -3/2, and the slope of the other line is 2/3. So one is positive, one is negative. That makes me start thinking perpendicular. And one is the opposite or the reciprocal of the other. One's 3/2, the other one's 2/3. So that would tell me that they're perpendicular. All right, very good. If you need to, take a look at the math and just see it fits and make sure it works with yours. Let's move on. Okay, on this point, they give us the graph on the right, a line and a point P off the line, and they want us to draw another line that's perpendicular to the line given, as well as being parallel. Okay, so two different lines. So the very first thing I would do is I'd go and find the slope of the original line. So I just found 2 points on the line and checked what the slope is, and I find it to be 4 and -3. That's how I got the slope in the green. Now they want me to find a perpendicular line. I'll do the parallel in just a second, but they want me to find the perpendicular one, so I'm going to do the opposite reciprocal. Then I'm going to plot that. Going off of point P, I'm just going to apply that slope to it. And there you have it. And I draw my line, and I've got it. Okay, the blue line and the green line are perpendicular. To do the parallel line, I'm going to use the same slope as my original, and I'm just going to go to P and apply that slope. I'm going to leave that for you to figure out on your own. Okay, on this one, we got to write an equation of a parallel line perpendicular to a parallel and perpendicular to the given line, and through the point 15 comma negative 4. Okay, to write my own equation, I always need two things: a slope and a y-intercept. All right, now the equation that they give me has a slope embedded in it that I need to use for both the equations I'm going to be building. All right, so the slope in this equation is 3/5, so that's going to be the slope that I'm going to be working off of. The parallel line is going to have that same slope, and the perpendicular one is going to be the opposite reciprocal. Now we'll keep those neatly off to the side as we build our two equations separately. Now, as I said before, we have two needs. We need to have a slope and then a y-intercept. So I'm going to build a parallel one, and I've already got the slope that I'm going to need for it. There's my standard form. So I bring my parallel slope and I stick it into my standard form. There it is, my standard form. Next up, I'm going to force this new line that I'm building to have this point right here as part of its repertoire of points. So I'm going to take that point, 15, negative 4, and I'm going to plug it in for the x and y in my half-cooked, if you will, equation. I still need to find this b, and I'm going to use this 15, negative 4 to help me solve for that. Okay, so I brought the double-lined, red-lined point down into the equation, and now I'm just going to solve for b. The 5 in the denominator cancels with the 15, leaves me a 3. Simplified, negative 4 equals 9 plus b, and now I just solve for the b. Okay, so now it's just a matter of taking this and plugging this into this almost finished, completed equation, and I'll have my final parallel equation that includes this point that they want me to do. And there I have it. All right, let's work on the perpendicular one. Okay, it's done the same way, but this time we're going to use the perpendicular slope. All right, so I calculate my b to be 21. All right, so there's my equation for the perpendicular line. It is negative 5/3 x plus 21. See, I found my b, and I calculated my slope, and I just put it together. Okay, using the same method, go ahead and apply it to this one. Let's just put me on pause, and then you can come back and check your work. If you're not sure what to do, you need to go back and review the problem I just did, follow along, do the notes, and then come back here and apply it. Saying you don't understand it or whatever requires you to go and Google it, find other videos, whatever you need to do, but you can't come to class and say you don't understand it. That's not acceptable. All right, very good. Go ahead and calculate this, put this on pause, come back and see me. And there's your two equations. So one of the things I absolutely love about the flipped classroom is I did these two problems in all my classes. In just these two problems, it took me almost 30 minutes to do just these two problems as I answered questions from people who got confused and weren't able to rewind me to see where a number came from. And in the flipped classroom, you have this lesson, you can just simply review back, rewind back. And if you have questions on some number, sometimes I make a calculation error, or maybe it just all of a sudden over here on the right, that -9, or over on the left, that -9 almost towards the bottom appears, and you're like, where'd that come from? And you can help me see that I've made a mistake, as I have. Okay, so let's fix that real quick. That should have been a +9. Okay, so that kind of changes our answer. Okay, and that ends up being a little bit better. Okay, well, there is your try it problems, all right? You should be able to use the problems I gave you earlier in this lesson to get 100% on these, okay? So if you get to one of these questions, you're not sure what it means, then you should go back and look at the video as well as your notes. Okay, your responsibility is to come in with a mastery of these three problems, then we can move into much deeper things. All right, till next time, take care.